Hi scholars, welcome back for another math lesson today. We're going to be working on problems where we have shapes with the same area but a different perimeter. So very similar to yesterday, except this time instead of the same perimeter, different area, we've switched them. All right, let's jump right in. So on today's agenda, very similar to yesterday, we're going to go over perimeter and area again, just to make sure we've really got it in our brains. We'll review some shape rules. We'll do a guided practice problem together. You'll try one on your own, and then it'll be time for the independent practice and your exit ticket. I'm ready. Are you ready? Okay. So the problem says, create a rectangle with the same area but a different perimeter. Looks like my length is 4 yards, my width is 5 yards. Okay, so to refresh my memory, perimeter is the total distance around the outside of the shape, so where this white border is here, right? Oftentimes we see problems where we're talking about like a fence going around something when we're talking about perimeter. Whereas area is the amount of space inside the shape. So where all this white shading is, right? So yesterday we said to ourselves, perimeter outside, area inside. That helps me to remember. A little song. We can't forget about shape rules. Shape rules are really important when we are solving these types of problems where we're playing with dimensions, with area and perimeter. So opposite sides of rectangles are the same length, right? So if a rectangle has a width of 7 centimeters on the top, the width on the bottom is also going to be 7 centimeters. Same with the right side, the left side and the right side because they are opposites. Next up is the square. All 4 sides of the square are the same length. So if I know that any of these sides is equal to 1 inch, I know that all of the sides are 1 inch. Same with an equilateral triangle, right? Remember, not all triangles are equilateral, but if you see a triangle where the sides look pretty much the same length, you could guess that it's an equilateral triangle, right? So if I know that one side is equal to 3 centimeters, I know that all the sides will each equal 3 centimeters. So, our guided practice. Step 1. We're going to determine the correct operation, right? Remember, our operations in math are addition, subtraction, multiplication, and division, right? So we have to remind ourselves, which operations do we always use to find area and to find perimeter? Okay, so I have that same problem here from a few slides ago. I'm going to remind myself, which operation do I use to find area? Think in your brain. If you said multiplication, you're right. We multiply the length by the width to find the area, or we multiply side 1 by side 2, however you like to think about it, whatever makes most sense in your brain. Now think again. What operation do I use to find perimeter? Turn and tell a stuffed animal, tell your dog, tell your mom, dad, grandpa. If you told them you add all of the side lengths, use addition, you're right. You have to add side 1 plus side 2 plus side 3 plus side 4. And we know that it doesn't really matter what order we add them in. It helps so that we don't accidentally add one twice, but you can add these in any order and you'll still get the same perimeter. All right, now that we know we're using multiplication to find area and addition to find perimeter, let's go ahead and figure out this problem. So step 2, I need to find the area and the perimeter of the given shape. So this is the shape they gave me. I know that again for area, I'm using multiplication. So I'm multiplying length, which is 4 yards, times width, which is 5 yards. 4 times 5, 4, 8, 12, 16, 20. That's 5 fours. So 20, and then am I done? No, I can't forget my label. In units for area, we always say square units, so square yards. Awesome. Okay, now it's time to find the perimeter. I remember for perimeter, I am adding up all of the shape sides. So 4 yards plus 5 yards plus, ooh, I know that this side is opposite this side, so it's the same length, so 4 again. And then the bottom is opposite the top here, so 5 and 5. Okay, so 4 plus 5 and 4 plus 5. Let's do a 10 here. So 4 plus 4 plus, I put my two 5s together to make 10. And then 8 plus 10. Whoops. It's a little bit bigger here, so I have some more room. And I get 18 yards. Can't forget to label. Okay, I'm not quite done yet. I found the area and the perimeter of the given shape, but I didn't answer the question yet. I still have to create a rectangle with the same area, but a different perimeter. So in order to do that, I have to test out dimensions. Dimensions, again, is a fancy word for length and width, right? I have to test out different lengths and widths to make a new shape, okay? So in order to do that, we have to remember the strategies that we used to find the area and the perimeter. And we have to remember to keep our shape rules in mind. So to find the area, I multiplied the length times the width. So let me move this over here. And I'm going to make a new shape here just so that we can play with dimensions. Maybe I'll make it look a little bit different. Okay, so I know that when I'm trying to find a shape that has the same area, that whatever length and width I multiply are going to have to equal 20, right? Just like before. So 4 times 5 equals 20. Whatever I multiply here has to equal 20. So I have to think back to my multiplication tables and say, what two numbers do I know that are different than 4 and 5 that also equal 20 when I multiply them? Does 3 times anything equal 20? No. What about 2 times something? Oh, wait, 2 times 10. 2 times 10 equals 20. Let's try that. Maybe I'll make this a little bit skinnier. I'm going to go the other way. What if this side was 2 yards, and this side was 10? I wonder if that will work. I have to check my perimeter and make sure. Let me make this white so that you can see. There we go. Okay, so what if this side was 2 yards and the width over here was 10 yards? That would give me an area that was still 20 square yards. Now let's check to make sure the perimeter is different than 18, because our perimeter for the given rectangle was 18 yards. So I have to make sure it's different than 18. So I'm going to add them all up and see. Is it not 18? 2 plus 10 plus 2 for this side plus 10 from the bottom there. Okay, let's see. 2 plus 10 is 12, and then another 2 plus 10 is 12. 12 plus 12 is 24 yards, and 24 is not 18. So we have successfully found a shape that has the same area, but a different perimeter. And was I able to keep the shape rules in mind so that my top and my bottom length were the same, and my, width. The top and bottom widths were the same, and the left and right lengths were the same? Yes, I was. I didn't have, random numbers over here like 3 or 9 or anything like that. Okay, now it's time for you to try one. All right, so the problem says, Miss Pariano wants to build a playground at EQ3. How fun. That is in the shape of a rectangle with an area of 12 square feet. Use the grid below to create 3 different rectangular playgrounds that Miss Pariano could build. Which of the 3 different playgrounds has the greatest perimeter? That's a lot of information, right? So before I let you try it on your own, let's think about, turn and tell your dog, your cat, your sibling, your family member, tell them, what is the problem asking you to find? Well, I can see that it's asking us to find 3 different rectangular playgrounds. And each one has to have an area of 12 square feet. That's why I put 12 square feet for the area for all 3 shapes. And then I have to find out which one has the greatest perimeter. So again, they're all going to have the same area, 12 square feet, but the perimeter is going to look different for each one. Okay. I encourage you to pause the video now and try it, right? You might not have a grid paper like this. That's okay. You can make one, or you can just draw the shapes on plain paper, okay? So take a second, pause the video, try to work on it a little bit on your own, and then when you're ready to come back, you can press play again. Welcome back. Hopefully you were able to try that problem, and I just want to say that before I go over it, if you came up with some shapes that look a little bit different than the shapes that I make, that's okay. As long as they have an area of 12, but they have different perimeters, that's okay. You still did it right. Okay, so the first thing I know I need to do is I need to create a shape, a rectangle specifically, and I need to think about what 2 factors, when I multiply them together, which length and width will equal 12. Gotta go back to my multiplication knowledge for this one. Maybe I'll try something with 2. 2 times 2, 4, 6, 8, 10, 12. 6. 2 times 6. Let me make a rectangle with a length of 2 and a width of 6. And I'll turn it red so that it matches, oops. There we go. So now we can see that shape A matches the red shape over here. Okay, so length of 2, width of 6. So far, so good. Let's add it up and find the perimeter. 2 for the left side, plus 6 for the top, plus 2 for the right side, plus 6 for the bottom. 2 plus 6 is 8, plus another 2 plus 6 is 8, and my perimeter is 16 feet. Okay, now let's think of some other factors or other that will multiply to 12. About 3. Is 3 times anything equal 12? 3, 6, 9, 12. Ooh! I could do 3 times 4. Let me make a blue rectangle on my grid to show 3 times 4. Do a length of 3 and a width of 4. And then I'm going to turn this blue. 3 times 4 equals 12. Now let's find the perimeter. 3 plus 4 plus 3 plus 4. Well, 3 plus 4 is 7, plus another 3 plus 4, another 7, equals 14 feet. Awesome, the perimeter is different than shape A. Let's think one more. Well, 4 times 3 would be the same, right? That would give me the same perimeter, so that wouldn't work. Same with 6 times 2. What if I did 1 times 12? That's a possibility, right? It'd just be really skinny. Let's try it. 1 length, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Count that one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. Always good to check again, just to make sure I didn't miscount there. And then we'll make this guy green. Perfect. Okay. So the area of my shape is 12. Length and width are 1 times 12. There we go. And now, same thing here, add it up. 1 for this side, plus 12 on top, plus 1 on the side, plus 12 on top. Oops, sorry, that's on the bottom. And what do I get? Let's see. Make this a little bit wider. There we go. 1 plus 12 is 13, plus 13 equals 26 feet. So there you have it, friends. We have 3 shapes with the same area, but different perimeters. Did I answer the question yet, though? No. I need to make sure I figure out which one has the greatest perimeter. And it looks like that is, what's the greatest? 16, 14, or 26? Think in your brain. Yeah, 26, right? 26 is the greatest perimeter. So shape C answers the question. If this is tricky for you, you can use your rolling numbers, or you can use a multiplication table to help. So this can help you to find factors or lengths and widths that will have the same product, that will help you to find the same area. So, for example, 2 times 6 is 12, and 3 times 4 is also 12, okay? I will add this into today's assignment, just in case you need it to help you. So for your independent practice, you are going to go back to today's assignment on Google Classroom. Today is the 5th. Make sure that when you click on it, that you click View Assignment to make sure that you can see all of the materials that are there for you. You're going to click on Independent Practice, Shapes with the Same Area, different perimeter. Don't forget to scroll down, make sure you've completed all the problems, and click turn in the top right corner. Then for your exit ticket, remember, we don't pick one or the other, it's both. Okay, do your independent practice and your exit ticket. It's not that much. Okay, then you'll go back to Google Classroom. It should be the 5th. You'll click on exit ticket, shapes with same area, different perimeter, a Google form, complete the activities, and click submit at the bottom. Okay. If you would like to read the rest of these reminders, I've gone over these a couple of days now. You can pause the screen and just take a look at these in case you need those reminders. All right, friends, our time is meow. Let's get started. I'll see you tomorrow.